There we go, Belle.
Okay, I think I'm there. Am I?
You are there.
Good.
Good.
So here we are. Okay, good. Finally, I had everybody minimized. I had to figure out how to make the screen bigger. All right, so here we are on our next to the last day of this, as Kelly was saying. Tomorrow is our last day of developing multiplicative thinking. Who's doing that session?
Honda.
Honda, okay. All right, and today we're going to talk about extending multiplication and division into multi-digit factors. And as Kelly says, I am Belle Rush. I'm a regional consultant with KCM, and I'm here in Bowling Green. There is my contact information if you need to or want to contact me with any questions. And we welcome you to go to the KentuckyMathematics.org site and look at all our great resources. All right, today's agenda, we're going to look quickly at some research having to do with multiplication, division with multi-digits. We're going to take a look at what our Kentucky standards say, then how to get there. We're going to look at those strategies for multiplication and division. All right, I want you to think about this statement. Most of us learn to add, subtract, multiply, and divide. I'm just going to throw all that in there. Whole numbers by lining up the numbers vertically and adding each column where we carry, borrow when necessary. But did we understand why it worked? Probably not. Most likely that how of doing the computation was drilled into our heads, but the why was lost. So that statement was by Bill McCullum. He was an author of the core content, the math standards, not our Kentucky standards, but the content math standards. And he also goes on to say that knowledge that's not supported by understanding is fragile, and we know that. I also want you to keep in mind that the standard algorithm is not a bad thing. It's been in use for years, and when it's used correctly, it works every time. And although the standard algorithm is often introduced in primary grades, the expectation in our Kentucky math standards is that they don't formally use an algorithm for addition and subtraction until grade 4, multiplication and division until grade 5. Why do you think that's the case? And go ahead and you can unmute yourself, or you can type in the chat and somebody will have to monitor the chat for me. Why do you suppose that is the case?
Most of the algorithms, they use place value, but they're so efficient that they hide the meaning of why they work and why place value is why they work. So if kids are still making sense of place value, they don't understand why those work. And so if we do it too early without the understanding, it is only a procedure. Yeah, conceptual first, he says.
Yes.
You need to know why it works and what they're actually doing.
Yes, all that why and all that understanding. And we've got to build that understanding. And here is again that graphic from Pamela Harris, where we move kids through this continuum where they're counting each thing by ones and even skip counting. They can do additive thinking where they're adding and still counting by ones, or skip counting, and then their multiplicative thinking, we move them through that phase. So we want to move kids through these phases, through this continuum, not let them get stuck where they're still counting. You know, we don't want 8th graders still counting things. We want them to see that multiplicative thinking, and we want to move them along to proportional and functional reasoning. And all of that is helping kids with their algebraic thinking. So that's that continuum. We want to move them along. And I've included that website there. You could go on her website, Math is Figureoutable, and you can download a questionnaire, just real quick. I think it's like 5 questions. Questionnaire, you can ask your kids these questions and find out where they are on that continuum. And you can also sign up for her your emails, her updates. I keep pushing the wrong button. All right, so what do our standards say? In 4th grade, our standards to multiply whole numbers, we multiply up to a 4-digit number by a 1-digit number. and a two-digit number by a two-digit number. And we want kids using all those strategies based on place value. We want to see place value. We want them to see properties of operations. We want them to use illustrations and concrete models where they could see rectangular arrays, area models, those things that they could see that are real to them, help them to see the mathematics. All right, in fourth grade with division, the standards say to divide up to 4-digit dividends by 1-digit divider with whole numbers and remainders using, again, we want to use those strategies based on place values, use properties of operations, use the relationship between multiplication and division. And we want lots of illustrations where kids can see and make connections to the equations with rectangular arrays and area models. And in 5th grade, they are fluently multiplying divided whole digit numbers, not to exceed 4-digit by 2-digit multiplication using an algorithm. What do you notice that says? It does not say the standard algorithm. They're using an algorithm. And on the left, you see the array, the area models, and then on the right, you can see an algorithm where they're breaking down those factors into smaller numbers, and they're using that decomposition of numbers and distributive properties. All right, also in 5th grade, we want kids to divide 4-digit dividends by 2-digit divisors using whole number quotients and whole numbers up to 4-digit dividends and 2-digit divisors. Well, again, we want them using strategies that are based on place value, properties of operations, and seeing that relationship between multiplication and division. And in 5th grade, they're building on what they have learned in 2nd, 3rd, and 4th grades. So they're building on that knowledge, and they're making lots of connections, and they're using those pictures and equations, rectangular arrays, using concrete models. So that is a look at our standards. Now, we're not going to take the time to look at this. I know many of you have seen these videos before by Graham Fletcher, where he takes you through the progression of multiplication and where it starts in 2nd grade, and even well, it starts in 2nd grade where kids are seeing equal groups and equal portions, and so it takes you all the way through that progression, and you can see how what they start at in 2nd grade is building in 3rd, 4th, 5th, and so on. All right, we're not going to take time to look at this 3-act task, but I love 3-act task. I wish that when I was teaching that I would have seen more of these and used these. Graham Fletcher, Dan Meyer, those are some of the gurus that are out there with 3-act task. In this particular one, well, let me say too that they recommend using a 3-act task at the beginning of a unit so you can get a feel for where your kids are. You could take that data, you could take what you see, and you can use that formative data to form some small groups, seeing what your kids' needs are. And then they also say you might want to use one through about midway through your unit so that you could see how your kids are progressing, if there are things that you thought they understood that they didn't. And then maybe right before you take your test, so you could say, ooh, I need to go back and review this real quick before they have their test. So in this particular one, it's called Sugar Packets. I've got the link there, but it's got this guy sitting in a diner, and he starts chugging all these sugar packets, and the people beside him are just looking in like that. But they're also slurping down their big Cokes, soft drinks. So then you ask the kids, how much sugar do you think he is consuming? What about this girl beside him? How much do you think there is in her soft drink? So then it shows them the soft drink, there's 64 grams of sugar in Coca-Cola. Of course, we don't have any idea what 64 grams, but then it tells you that in his packet of sugar, there are 4 grams. So then the kids, they can work through and figure out how much sugar that is consumed in a Coke, and it may surprise them. And they get lots of, you get some insight into what your kids know. So the 4 strategies for multiplication that we're going to look at today came from Making Number Talks Matter, and this is what Bonnie has done her book study on. So I took some of the strategies that they have, and the strategies that we're going to look at are break a factor into add-ins, factor a factor, round a factor, and adjust, and then having and doubling. And the first strategy is here, break a factor into 2 or more add-ins. And then in this example, they have 12 times 16. So they've taken the 16 and they broke it into 10 plus 6. So then they can multiply 10 times 12 to get 120, and then 6 times 12 to get 72. So they break one of the factors into smaller, more manageable numbers. And here is Dreambox Teacher Tools. You can use Dreambox Teacher Tools whether your students subscribe to Dreambox or not. Anybody can use the teacher tools. And here, are y'all seeing that? The Dreambox, did it go?
Just seeing the PowerPoint.
No, it did not show the Dreambox. Well, shucks.
You've shared just the presentation. You actually didn't share screen, which is probably good for sharing the presentation. But when you are, we can only still see the PowerPoint.
Okay. Is there a way for me to make this where you all can see this? What do I have to do? It says you are screen sharing. Stop share. I don't want to do that.
When you click on the thing in your presentation, what happens?
I have gone to the Dreambox site.
So you literally have just the presentation shared, not your browser. So if you share just the browser, it should share both.
Well, not sure how to do that. I'm sorry. Not that good on this yet. All right, so you all are still seeing my presentation.
One of the things that we can do, Belle, is we can go to that site. So
okay,
I'll try to type that in the chat, and we've had a lot of success with that.
Okay, thank you. Just wonder if there's if I could figure that out while you were doing that. All right, so if you go to that Dreambox site, to the teacher tools, it's got things divided up by grade level, and it doesn't have a tool for every activity that you might want to do. But if you'll scroll down on that site to 4th grade, multiplication and division.
I'm in there.
Okay.
Belle. Yep, I'm in there.
You'll see multiplication, open arrays. And then when you go, okay, and then go to view teacher tool.
Yep.
And it's going to show you, well, it says before you continue, yes, we do agree. And it's going to call us all Jennifer. We're all, we're not stealing Jennifer's page.
Sorry, I think I'm sorry. I'm not
okay.
muted. I like that it's in Spanish too, by the way.
Yeah, it's super cute.
And you've got a little zipper there. We'll give you a multiplication problem over on the left, and you've got an array that you can grab that zipper and you can break the big array into smaller portions where you're decomposing your numbers. And one thing I discovered by reading the directions, which I don't always do, I usually just jump right in and start doing. But I did discover by reading the directions that you can take that zipper and you can get it about where you want it, but then you can use your arrow keys because it is kind of hard to get the zipper exactly where you got like 70 or 50, where you get your manageable numbers, where you get your friendly numbers. So you can use the arrow keys to move up and down. And then you could put in your equations where you're breaking that array, where you're breaking that area model into more manageable numbers, and you break it down, and then you add up the products to get your final answer. So I'm sorry I can't show that. Are there any questions about it? I don't know if you want to take a few minutes. Or I would suggest, how about if there it is, there, go back and look at it. But it is the multiplication under 4th grade. Were you going to say something, Kelly?
Just going to say that it was super cute the way that there's that zipper that extends the information from Leah yesterday. And so I love that there's that progression that we're beginning to see. So thank you. But Dreambox is it really is a nice site. So these are good teacher tools. Thank you for showing those to me, especially if I can use them kind of a little sample lesson.
Yes. Yeah, and they've got all the K through 6 on there, and you can kind of pick what you want. They don't have everything for the teacher tools, but it's free. All right, and then there's also factors and multiples. I've included this game in your packet, but there's also a link there. I hope we could go to that link, but I guess I'll try. I don't think it's going to show up on your screen. But actually, Lisa showed this same activity yesterday, if you attended her session yesterday or the day before. Are you all seeing that screen, that game? Probably
yes.
not.
Yeah,
oh,
we can see it.
Okay. Wonder why that one shows up, but not Dreambox. But this one, you pick any number between 1 and 50, and you drag it over here on this side, and you can play with a friend, you can play by yourself. So I've got 25, and I could think of a multiple or a factor of 20. There's a 25, and then so now I've got 5, so I'll find a multiple or a factor of 5. Let's see, I'm going to go with 15. All right, I find a multiple or a factor of 15. I could go with 3. And you just keep finding multiples or factors of that number and dragging them over. And whenever you drag one that is not correct, let's try one that's not correct. Let's say I try something that's not correct. It's going to give you a little blue circle. So then you know, well, I've made a mistake. So, but your point is that you try to make as the longest string that you can with multiples and factors. So that's just a way of helping kids see multiples and factors. All right, so yeah, that's factors and multiples game. And there is a hard copy in your packet because I know a lot of your kids don't have internet access. Whoops. All right, the other strategy that's in that Number Talks book, and just let me say real quick, the Number Talks book, these strategies are things that you want your kids to come up with these strategies, but here are ways that you can record them. And the thing I like about that Number Talks book is that it doesn't say this is how you do it, but it gives you, if you want your kids to do this factor type of strategy, it gives you some problems that you could present to your kids that actually help your kids think about those type strategies. So here's factor a factor, where you have 12 times 16, where they factor out the 16 to 4 times 2 times 2. And then that makes it a little bit more manageable, where they can multiply 12 times 4 is 48, times 2 is 96, and then 96 times 2 is 192. So there's that strategy. And then there's factor track, and I'm looking at the time, and we're not going to have time to look at every game, but I do want to show you real quick this factor track. It has a practice section on there, and I've also included it in your packet, a hard copy. This practice page, are you all seeing this screen with the game?
No,
Well,
No. Okay, if you go to that site, it has this easy, it has like a training track. You have to go through the, and your kids do, and I had to go through that training track to say, what are they trying to do? What am I trying to do? So, well, and I did that through the little training site. And by the time I figured out what to do, I thought, well, this is easy. But then you scroll down to the real game. The little short one, the training is basically, it's a training. It lets you know what to do. But then the one that you see on the screen here, that's the real game, and it's a little bit more complicated. You got little shortcuts you could take, and you have to figure out, well, does that shortcut really help? So it was kind of a kind of, you had to think about what you're going to do, what your strategy was going to be. So I like that little game, and it got kids thinking about the different factors and the numbers. All right, then the other strategy is round a factor and adjust, where they have 12 times 16 rounded up to 20. So you're going to multiply 12 times 20, and then you have to go back and take that extra where you added, where you multiplied into many groups. And then there's multiplication race. Now, when you look at this game, the reason I like this game with that strategy is because this is from K5 Math Teaching Resources. The numbers that are used on this are numbers that you can look at those and say, oh yeah, there's 296. I can round that to 300. So it's easy to round the numbers that are in this game. And then halving and doubling, I've shown this at another one of these make a take sessions. The halving and doubling, where you have 12 times 16, you can double one factor and halve the other factor until you get it to some manageable numbers. So here they took 12 times 16, they doubled 12 to make 24, and halved the 16 to make 8. So then they kept doubling and halving, and then they could do that in their head. So it's about mental math, doing it mentally. Is there any questions on that? I know I haven't stopped for questions at all.
Now, one of the things that we're doing that you may not see is that we're putting the links for those. So when you're referencing something that isn't clicking, then we're able to put that link in the chat. So that's been very helpful. So thank you, Cindy and Dee, as we're doing that.
Yes, thank you all. And I've also included in your packet, there are hard copies of these games too. So then this game is also from K5 Math Teaching Resources, and it's using that strategy, halving and doubling. And it's got your direction sheet, your game board. And then what I like about this one is over on the right of this screen, you see it's got little sentence starter, a little, something for the kids to get that discourse going, where they can say, well, I know that half of 50 is 100, so half of, or 25 times 6, I can double and half. So it kind of gives them a framework, what to say to get that discourse going. So I like that little feature in that game. All right. Any questions about any of those strategies or anything with multiplication? All right, we're going to move on to division. And again, we're not going to watch this video, but I've linked it here that you can go back and look. I think they're really good to see how it starts. Even in kindergarten, first grade with fair shares, kids are getting that background knowledge and how it all builds up. All right, and again, these strategies are taken from Making Number Talks Matter. And the strategies we're going to look at are multiply instead, chunk out, make a tower, halving, and halving with multiplication. And I want you to think about these strategies for division. When this first statement was written by Richard Anderson. He was the president of the Mathematics Association of America 30 years ago. And here is something that he said more than 30 years ago. When computers and calculators truly come of age in the schools, which they have, paper and pencil long division will probably be as dead as a dodo bird. So this Meyer, in some of his research, he also goes on to say, there is no longer a job in the world, not one single job, where someone does long division with paper and pencil. Not one job that is, except teaching. Now, this is not to say kids don't need to know how to divide, because they do, but they need to understand division. Using the long division algorithm, it may not be anything they ever used in real life, but they do know they need to understand how division works. So through number talks, they can make sense of division, the operation, not the standard algorithm, and it helps them to maintain a focus on the relationship between quantities. They learn how to size up a problem and determine a reasonable ballpark answer. That statement comes from Kathy Humphreys and Ruth Parker, the authors. All right. One of their first strategies is multiply instead, where they think about multiplication to solve the division. All right, right here you've got 17 divided by 3, and you notice the way it's written. We also need to let kids see all these different division symbols, not just the same one all the time. So 17 divided by 3. They could think of that as, I know 3 times 5 is 15, so I have 5 groups and I have 2 left over. So there's a remainder of 2, right? And I looked at Orgo at home, and I think Lisa showed this. Orgo at home, for each grade level, there are 9 weeks of lessons, and for 4th grade, there is one on multiplication. And so it gives you something on Monday, and for grades 3 through 5, they're mostly number talks where the kids watch a number talk. They can't participate, but they can watch and see what other kids say. Tuesday, there's hands-on math, Wednesday, problem solving. Thursday would be game day, and Friday is practice. And we're not going to have time either to go to this game. Well, let me see if it shows up for you guys. Does that show up?
Not the game, but just your PowerPoint.
Okay. All right, with that game, let me come back to myself here. With that game, they play it with 2 players. One player has a blue counter, and the counters are over here, and they can move their counters on their screen. So then they roll the cube that's up at the top, and whatever number they are on, like the blue counter is on 15. So if they roll an 8, they would divide 15 by 8 and see what their remainder is, and whatever their remainder is, they can move that many spaces. If they end up with something with no remainder, then they don't get to move. So that's something where they're thinking about their multiplication to find their division. I chunk out. This game is where this strategy. You don't want to teach a strategy, but you want your kids to come up with these strategies. So if they have 643 divided by 30, they're going to take out chunks of 30. So maybe they might think, well, I know that 30 times 20 is 600, so I could take out that big chunk. So they start taking out chunks, and then they end up adding up what their numbers were, the chunks that they took out to find their answer. All right, and there is another game from K5 Math Teaching Resources where they call it Partition the Dividend, and it's doing the same thing. It shows them an example there on the direction page where they are taking out chunks. All right, make a tower. With this game, your divisor is 13, so they make a tower over on the left, starting at the bottom. They make this tower. 1 times 13 is 13, 2 times 13 is 26, 3 times 13 is 39, 4 times 13 is 52. Well, if I do that 40 times, it gives me 520, which is close to over here where I could take that out of 300 or 531. So they're making a tower of their multiples of 13. The game that goes with that, again, there's Dreambox teacher tools. This game is it's a gumball machine where they can take out bags or chunks of their divisor. So they could take those chunks out. And if you want to have your kids make that tower of the chunks of 25, so they could figure out how many, or the chunks of their divisor, to take that many out over there. So that game kind of goes along with chunking it out. All right, then partial quotients. Here's another game from K-5 Math Teaching Resources to help them take out those chunks, and they can look at those the chunks over there. So that game is also, there's a link to it, and again, I've included that in your packet. And then having instead of having and doubling. With division, you're going to have and half. So if you start off with 128 divided by 32, keep cutting those in half until you get down to a manageable size, and then there you have your answer there. So let your kid, that's probably not something your kids are going to come up with, but you might want to do some work with some graph paper and area models and have them to see how that works. All right, all of this works with any numbers, including fractions, decimals, negative numbers, proportional numbers, functions. It all works across the board. These strategies help students to make sense of the properties of operations, which leads us back to that Pamela Harris, that continuum. We want kids to have that algebraic thinking. We want to move them across that continuum and help them see these strategies, helping them see the properties of operations, the properties that they use in 2nd, 3rd, 4th, 5th grade with whole numbers are the exact same properties that they're going to use when they get into calculus. The properties are the same. So we're teaching them to use those at a very early age. All right, any comments or questions? And I see that it is 1:30 or 2:33. Any questions, comments? One researcher, Phil Darrow, says that you cannot do mental math without doing algebra. This is algebraic thinking at its purest level. The properties are the same in 3rd grade as they are with calculus. So we're teaching them all that. I'm sorry, any questions? I started talking again.
Lots and lots of really good resources.
Thank you. And here's a quote that I just like. The best teachers are those who show you where to look, but they don't tell you what to see. And again, we are here to support you all. If you have any questions, I know I'll talk fast because I tend to overplan. So if you have questions, please, there's my email. Just let me know. We have one more of these sessions tomorrow.
Well, thank you. Lots and lots of resources. All of a sudden, I felt like I had a big old bucket full of stuff, and you persevered kind of over the little tech glitch that we had. But thank you for what a great series of kind of just lessons. We are going to offer something special at the end of this session. Our friend and regional consultant Cindy Aussie she's the be-all know-all of Jamboard. That's what we've just decided. And so if you want a little informal meeting, we are going to, I think, stop the recording and take a look at a little bit of Jamboard. And so we are going to transition straight into that as Cindy does that for us. But we want to thank each of you for joining us this afternoon. We've got one more Zoom session. It is the last of our developing multiplicative thinking. And so we'll see you tomorrow at 2 o'clock.
Thank you all.
All right. Thanks, Belle.